Hello again. I am wearing another Santa hat. This time it's an Eagles hat. I should point out that I am a Chicago Bears fan, but my husband is an Eagles fan, and we happen to have this hat, and it's Christmassy, and the Eagles have the best record in football right now, so I figure I can support them since the Bears are not having that great of a season. So, Merry Christmas, Eagles style today. So in the first part of this section, you guys looked at finding or identifying linear versus nonlinear functions from graphs and then from tables, and now we're going to look at the equations, how we can tell just by looking at an equation if it's linear or nonlinear. So first of all, if it's going to be linear, it has to be able to be written in this form, y equals mx plus b, where m is the slope and b is the y-intercept. If an equation represents a nonlinear function, it's going to have one or more of these characteristics. Powers on the variable are the ones, so for instance, x to like the second or x to the third or x to some other power. Square or cube roots of variables, like the square root of x or the cube root of x. Variables in the denominator of a fraction, like y equals 5 over x. So here's an example of some different types of nonlinear equations. And also, we are on page 298, so you'll see these graphs on page 298 as well.
There are several characteristics that can be used to identify a nonlinear equation. For instance, if the simplest form of an equation includes a variable with an exponent other than 1, then the equation is nonlinear. For example, the equation y equals x squared plus 3 is nonlinear because the variable x has an exponent of 2. A graph confirms that this equation is nonlinear. This equation, y equals 4x cubed, is also nonlinear because the variable x has an exponent of 3. Another type of nonlinear equation includes a square root or cube root of a variable expression. For example, this equation is nonlinear because it includes the square root of the variable expression 2x plus 3. The graph shows that this equation is nonlinear. A third type of nonlinear equation includes a variable in the denominator of a fraction. For instance, the equation y equals 2 divided by x is nonlinear because it includes the variable x in the denominator of a fraction. The graph confirms that this equation is nonlinear. You have now seen some of the characteristics that can be used to identify nonlinear equations.
Now there are going to be linear equations where x could be in a fraction, but the difference here is that it cannot be in the denominator of a fraction. And we're going to look at an example on page 299 where x actually is in a fraction, but it's not the denominator. So if you have this equation and we want to tell is this linear or nonlinear without graphing or anything, y equals x over 3. Remember that in front of x is the number 1, even though it's not written. So we can actually rewrite this as y equals 1/3 x. So x over 3, when x is in the top of the fraction, that's the same as 1/3 x. And if you think about it, 1/3 times x, if I were to multiply that out, would just be x over 3. So we can rewrite x over 3 as 1/3 x. It's the same thing. So is this equation now in the form y equals mx plus b? And in fact, it is. The b is 0, but the slope is 1/3. So this is a linear function because it can be written in this form. Let's look at another example. This one's not in the book. You can put this in the margins on page 299 if you want another example. Here's another one. So is this in the form y equals mx plus b? Be careful, there is an exponent, but the exponent is not with the x. So technically, this is really y equals 3x plus 16. So because it can be written in this form, y equals mx plus b, it is a linear function. So there is an exponent, but it's not with the x. So 4 squared is really just 16. So they're trying to trick you here with that. Try the check problem on the middle of page 299 and see if you can tell if that one's linear or not. And then example 5 on page 299, is this a linear or nonlinear function? Again, without graphing from the equation, you should be able to tell. Here, there's no way this can be written in this form. Because I have an x squared, I have an x, you can't combine any of these terms. So because we have a power other than 1, x is raised to a power other than 1, this one is nonlinear because it cannot be written in this form. And that's really it. So linear and nonlinear, if you're looking at the graph, it's really easy to tell, and hopefully looking at the equation, it's not so bad. The only one that's a little tricky might be looking at the table. But try the check problem on the bottom of page 299, and that's all we've got for today. Go Eagles, go Bears, even though the Bears aren't going to make the playoffs, but still go Bears.